Hello everyone and welcome to this tutorial video for PROG1198. Today's topic is computed columns, so let's get started. A computed column is a virtual column that is not stored as part of the table, but instead calculated based on other field values. So what this means is, for that particular column, it's created as part of the table. However, no values are stored unless you specify that you want them to be stored. By default, in a computed column, what you store instead is a formula indicating how the value is computed for each record. There's no need to indicate a data type on a computed column because the type is determined automatically by the calculation results. When you're creating the formula for a computed column, the calculations can use functions or any other kind of calculation typical to what we're used to writing in other versions of TSQL. It's similar to when you create a calculated field. However, a computed column is stored in the database instead of written in the projection. When you're writing the formula for a computed column, you can refer to data stored in any of the other fields from the same table. Note that when you change the associated data in the table, the computed column data updates automatically. And this is because the data is generated by referring to the formula that you've stored. There are two ways to add a computed column into a table. You can either add it as part of the table create statement when you're generating a new table, or you can add it to an existing table using an alter statement. In this first example, you can see how I've added a computed column to the create statement for the employee table. So we have added this field called emp years employed, and the purpose of this column is to tell us how many years each employee has been employed at the company. Now this is something that we want to calculate and not store. Because if we store data like this, it creates a problem for maintenance, because every time that employee's anniversary passes, we would need to update their years employed. This is something that we can easily calculate because we know the employee's start date. So rather than calculating it in the projection, we can store the calculation as a computed column. So when we're defining the columns for this table, we define the column that's going to be computed by giving it a column name, using the keyword as, and then writing the formula for the calculation. In this case, the calculation for years employed takes the date diff, that calculates a difference between two dates in years, between the start date and the current date. Notice the call to the getDate function here to return the current values for date. Notice there's also no data type associated with this. We just have a comma and then we go on to define another field at the end. Let's take a look at this example in SQL Server. So this is the script that we've been using to create our company database, and in here we find our employee table create statement. So we can add the computed column by indicating the column name as, and we're going to put the formula here. Now you don't need to have parentheses around the formula, I just put them in there as a placeholder. I'm going to pause the video while I type the rest. So I've typed in the formula here for emp years employed. I'm going to execute the script to remake the database, including this new version of the employee table with emp years employed. Now we've got our employee and department tables created. I'm going to come over here and select all from employee so we can see the results of the computed column. So it looks and acts just like a regular column, but this data is not actually stored as part of the table. It is computed when we call on it. Now, the other option for creating a computed column is to add a column like this to an existing table. So rather than having to drop our entire database and remake all of our tables, usually that's not a good solution when we just want to make one change. So if we had, modified the data, we would lose all of our changes unless we have to go through the whole backup and restore operation. So ideally, we would just want to alter a table if it was already existing and we just wanted to add something on. So here's the syntax for adding a computed column to an existing table. We start off with alter table and the name of the table, and then add, and the column definition is the same here. So we give it a name, as, and then the formula that calculates the results. One thing I want to point out, this formula includes a call to a method or a function here called getDate. And notice that every time you call getDate, it has a unique result to it. Now, a note about one of the options on a computed column called persisted. I said that by default, computed column data is not stored as part of the table. However, if you do want to store the data as part of the table, you can add the persisted keyword to the end after the formula at the end of your computed column definition. However, there is a catch. Not all values can be stored as persisted. They can only be stored if they are deterministic. And I've put a link here to Microsoft's definition of deterministic values. So let's take a look at that. So this link gives us a formal list of what makes an expression deterministic, but essentially what it means is that given the same inputs, you will always get the same outputs. Now when we're calling getDate, we don't even provide any inputs, but we always get different outputs for calling getDate. So including getDate in our expression for the computed column is what makes it non-deterministic. If you're calling a function that for the same inputs always returns the same answer, then you can choose to use that as a persisted column. I'll show an example. Let's say, for example, we wanted to create a computed column that shows the employee's full name. So I'm going to perform an alter statement on our existing employee table that creates a computed column generating a string, a combination between emp first and emp last. I'll pause the video while I type. So here's an alter statement that's going to add another column called emp full name as a concatenation between first, a space, and last. Now, this concat is calling a function, but given these three inputs, concat will always return the exact same output. So it's a deterministic function. Let's execute this. And we can take a look over here at our employee full name column. Now, when I added this column, because the function was deterministic, I could have chosen to make it persisted. Let's do the example, same example, but we'll make it persisted. All we do is add the persisted name at the end. So what's the difference? The difference is in how things are stored. With the first one, it was not marked as persisted. It's just calculated when we need it. With the second one, those values are actually stored as part of the table. So the pro of persisting data is that when you query it, we don't have to perform all the calculations. The con, though, is that it uses more storage space, and we're introducing some data redundancy because now all the named things are stored twice, right? So you really have to kind of consider the trade-off between those two. What are you more concerned about, calculation time or storage space? Now, can we insert or update to computed columns? Well, it doesn't make sense to be able to. if the field values are calculated based on the results of functions or other calculations from other fields, then it doesn't make sense that we would be able to set our own values in there, because any changes to that data would violate the formula that we use to calculate that data. So let's take another look at this. If we have our employee table here, we look at the emp years employed computed column. We have a 31 here because we've calculated how many years between employee start, 1991 June, and the current date, which is January of 2022. So 31 years have passed. It wouldn't make sense for me to be able to modify this value. So if I try to modify the value with an update statement, and change this value where emp id equals 1, you can see that I'm getting an error here. Invalid column name. That's an error not because of the computed column, it's just my system hasn't updated yet. When I execute it, we'll see the real error message that the column cannot be modified because it is a computed column. And the same goes for insert. If I try to insert a new employee, I can't provide a value for emp years employed. It's just calculated and either stored if it's persisted, or it's just calculated on the fly. So you see this error message here when you try to do that. Now, we've already seen one example of querying the data. I did select all from employee to display all of the fields, including the computed columns. The computed column doesn't need to be treated any differently in any select statement. So we can use the computed column just like we would use a regular column. We can put it in the projection, that's the select line. You can put it in the where line like we've done in this example here. It says where emp years employed between 30 and 35. The emp years employed is our computed column, and we just reference it just like a typical regular column. You can put it into the order by line, so there's no difference in the way that we treat it. It's only difference in the way that the data is generated and stored. So let's try this example. We're going to select all from employee, where emp years employed is between 30 and 35. When I execute that, you can see it performs that query with the where line. Now, if we take a look at our employee table columns, you'll be able to see in the column definitions that computed columns are denoted as well. And you can see that the data types for them that have been generated are dependent on what we indicated that the formula would be where they are calculated. So emp years employed is an int because date diff returned an int. Emp full name and full name 2 are varchar 56 because the concat function is concatenating something that was size 25 plus one additional space, that's one more character, so we're at 26, plus 30 more, so that's why varchar 56 is the size of that column. So the data types you don't have to deal with. Now in a future class, once we learn about writing our own user functions, you'll see how we can call our own user-generated functions as well when it comes to creating these. So we can write functions that determine how the values are going to be calculated and then call them as a computed column. So I'm looking forward to discussing that in a future video. Until then, If you guys have any questions about computed columns or anything else, please feel free to email me or drop into any of our Collaborate sessions during the week. Until then, I'll see you next time.